Alright, so now we are on page 3 of the notes. Now we're going to talk about a new number. It is the number e. And it's a number that has a special name. It's similar to the number pi, where it's some specific number and we use that symbol pi to denote it. Same thing here. E has a specific value, and the actual definition is that it is the value that 1 plus 1 over n raised to the n power approaches as n becomes large. So what this is saying is you plug in some number here and here for n, and then find out what that is. Then you plug in a different number here and here, a bigger number here and here for n, find out what that is. And then you keep plugging in bigger and bigger numbers for n, huge numbers, and this whole value will get closer and closer to one specific value, and we call that value e. So to demonstrate that, I'm just going to fill this chart in. So here we have this expression and different values that we're going to plug in for n. So I'm just going to use the calculator for most of these. So say we plug in the number 1. So we get 1 plus 1 over 1. So that's 1 plus 1, which is 2, raised to the 1, which is just 2. So I don't need a calculator for that one. Everything else I do. So now I'm going to plug in 1 plus 1 over 5, take that raised to the 5th power. Get about 2.48832. Okay, and then I would do the same thing for 10 and 100, and I'm not going to do it right now, but if you did use a calculator, the next couple numbers we would get are 2.59374. If we plug in 100 for n, we would get 2.70481. If we plug in 1,000, we get 2.71692. If we plug in 10,000, we get 2.71815. If we plug in 100,000, we get 2.71827. So you can see we're plugging in these larger numbers, but the number over here that is getting spit out is not changing too much now. And then I'll just do this last one. Plug in a million. 1 plus 1 over a million raised to the millionth power. Get about 2.71828. Okay, so, and that's about how far it's going to get using a calculator. So this number, it's getting closer, it looks like, to about 2.718. And so approximately, E turns out to be about 2.71828459045, and it keeps going and going forever, just like the number pi does. Okay. So up here, E is just approximately 2.718. So this leads us to the natural exponential function. So it's just an exponential function where the base is e. And another name that people call this function is just the exponential function. So if you casually say it's the exponential function, that means they're talking about the one where the base is the number e. Okay, so to practice using e, we're going to use a calculator to evaluate these expressions and round to 5 decimal places. Okay, so on my calculator, in blue right there, it says e to the x, so I have to press second and then that button. So second e, so I have e to the third power. So that's about 20.08554. Approximately 20.08554. Okay, do another one. 2 times e to the negative 0.53. It's approximately 1.17721 if I round to the nearest to 5 decimal places. And do e to the to the 4.8. Oops, put in the wrong number. E to the 4.8. So it's approximately 121.51042. Okay. So you definitely need a calculator to be able to do those. All right, and then now let's talk about graphing this function. But it's just an exponential function, just like on the first couple pages, so you graph it the same way, except this number e is about 2.718. So, since e is approximately 2.7, the graph of f of x equals e to the x lies between the graphs of f of x equals 2 to the x and f of x equals 3 to the x. So in this picture, you see 3 of exponential graphs. The one that's the steepest is 3 to the x. And then the one that's the least steep over here is 2 to the x. And then this one in the middle right here is e to the x. And then note that function e to the x, it still has the points 0, 1, and 1, comma e, just like the other a to the x functions. And then it also has this horizontal asymptote still at y equals 0. So really not any different from the last page or two. Okay. So talk about graphing the exponential function e to the x. Just again, we're just gonna basically use our knowledge of transformations for these examples. So first, explain how the graph of g of x equals 1 plus e to the negative x would be obtained from the graph of regular e to the x. Well, this minus here tells us that we need to reflect across the y-axis, and then this 1 is being added on to this function, so that tells us to go up 1 unit. So if we talk about the horizontal asymptote, if everything's moving up 1 unit, so is the horizontal asymptote. So this one for this function would be y equals 1 instead of y equals 0. Okay. And then we'll do one example of actually graphing. So I want to graph this function g of x equals 3e to the 0.5x. But I am going to use a calculator to help me. So I'm just going to plot some points. I'm going to create a t-chart. I'm going to plug in -3, -2, -1, 0, 1, 2, and 3. And let's see. I can actually kind of have my calculator create this table for me. So I'm going to graph the function because my calculator can graph, and then I can press, I want my table, so second table, and I'm going to plug in these values. And so here I just asked it to plug these values in. It's a faster way. So I'm just going to copy these values over here. Approximately, I'm going to round them. This is going to be about 0.67. If I plug in -2, it's going to be 1.1. If I plug in -1, I get 1.82. If I plug in 0, I get 3. If I plug in 1, I get 4.95. Plugging in 2 gives 8.15, and plugging in 3 gives 13.45. And then as far as the horizontal asymptote goes, if you look at the function itself, are we moving up or down compared to the original e to the x function? We're not, because there's no like plus or minus some number on the end of it. So the horizontal asymptote is going to stay at y equals 0. Okay, and now I need to graph it. So here will be my x-axis. Here's my y-axis. And then I'm going to go by ones down here. And then I'm going to go vertically, I'm going to go by 3s. Because I see that I have to get up to like 13.45. So I know my horizontal asymptotes here. And then I have the point -3 point and then up 0.67. So this is 1, 2, 3, so it's going to be a little bit below that. Maybe about there. And then I'm plugging in -2 and up 1.1. So that's maybe about there. Plugging in -1, we get almost 2. A little higher. Plugging in 0, we get 3. Plugging in 1, we get almost 5. So 4, 5 might be about there. Plugging in the number 2, I get 8.15. About there. And then plugging in 3, we get 13.45. So 13.5. About there. And then I can just fill this in. And that is my graph of that function. Alright, so this concludes the 5.2 node outlines.